All right, hello and welcome to Lab 5. This one is going to take some drawing, so I'm going to use my office hours PowerPoint as scratch paper for us. This one is all about rational numbers, and I really encourage you to use the 2 weeks to do this one and not Lab 4. Lab 4 is so much easier. You're also getting 2 weeks for that, but the time between Lab 4 and Lab 5 being due is 1 week. So I encourage you to finish Lab 4 early because it's easier and work on this one. Okay, with that in mind, let's get started. So your program is going to revolve around these things called rational numbers, which are just fractions. This is just a fancy math term for fractions, a over b. So an example rational number is like 1/2, or I don't know, negative 42 over 11. And we normally like to work with rational numbers in a simplified way. So if somebody ever types in, I don't know, 4 over negative 8, you want to somehow magically convert that before you work with it, because it's easier, to negative 1/2. Like put the minus sign up top in the numerator, and then simplify the numerator and the denominator by some amount. And the magical amount that you use to simplify with just so happens to be the greatest common divisor. If I can spell. Isn't that nice? So it just so happens that the greatest common divisor of 4 and negative 8, or 4 and 8 positive 8, you're going to have to convert them to positive numbers before you do this. GCD of 4 and 8 is 4. And so you can then use the GCD by dividing by GCD and moving negative sign up. You just have to go and convert 4 over negative 8 to negative 1 over 2 using GCD. That's all you have to do. Give this number, give those two numbers to GCD, the numerator and the denominator. You'll get back a value that you can then divide your numerator and your denominator by to get back a mostly simplified result. The last thing you need to worry about is moving that negative sign up into the numerator. Okay? And then you have a fully simplified, glorious fraction, or rational number. Whee! Okay, so that's the idea. I think that's all I needed to draw for you. So you're going to implement this in code. You're going to make a library, a rational number library, and it's going to be in rationals.h is the declaration. You don't touch rationals.h. Rationals.cpp is where you do your magic. And that's where you're going to implement stuff. All right, so am I in the starter code? Yes. So you have these files. Here is rationals.h. Here are the three files the three functions that you'll be implementing. So rational pretty string, so this takes a rational number that's separated into numerators and denominators and gives back a string. A pretty nice looking string form of that, with some slashes and some spaces, things like that. Then you're going to implement multiplication. So given one rational number, its numerator and its denominator, and another one, numerator and denominator, you're going to make a new one, and you're going to edit these values because it's passed by reference. Changing result numerator changes whatever value was passed along. Same for this one. And you're going to change these to be whatever the result should be. Okay? And then it will have propagated. And then finally, the rational simplify function is the one that you will call to, given some values for numerator and denominator, to go in and edit those to be the smallest that they should be using the greatest common divisor. Okay? So now if we look at rationals.cpp, I have given you GCD. We implemented in that in class, so it doesn't really do much to have you just copy my code anyway. So here it is for you. You can use that in your rational simplify function, and I've shown you what needs to happen. Same for times, and you want to simplify before you do or after you do things. Okay, and calling rational simplify on your numerator and denominator will simplify something. It will change the things. Okay, and then finally, pretty string just takes some numbers and makes strings that look nice. Okay, and you'll implement that. Finally, once you're done with all that, You can run the sample program.cpp, which just does all this for you, just tries to test your stuff. You'll enter numerators and denominators, and it'll print the stuff out to you. And hopefully, if you do this and you get the same answer, you're pretty much all the way there. Okay? The final thing, or a couple of things that you need to do after that, is I have made test cases. Okay? And those live in test.cpp. Here they are. I use this assert true function to give it some Boolean value, make sure that it's true. If it's not true, the test failed. Okay? So I made these 3 tests for you that test those 3 functions. And yeah, they're going to run, and hopefully they will print all passed for you. And if they don't, you're going to have to start debugging. Okay? So you want to see this output. If you see failed somewhere, you're going to have to start debugging. All right? And then finally, just to get you in the hang of doing it, you're going to write 2 of your own tests. Okay? You can do it in this style that I've already written. They should call this assert true function. Okay? That's all. Test whatever you want. And that is your program. So you're going to make a library, and you'll turn in the library implementation, the .cpp file, and you'll also turn in the tests that you wrote in test.cpp. Okay? I guess the only other thing I want to tell you is make sure when you're compiling now, because we have multiple files, to use them both. You're not just compiling sample program anymore. You're compiling it with your library, with your rationals library. And so G++ needs that implementation file, even though sample program just needs to include the .h file. Okay? G++ needs to put that code somewhere, so it needs to see the real code. All right, so good luck with that. Rational numbers are going to be fun and exciting. And yeah, that is all I want to say there. So get that 4 over -8, get it simplified into -1 over 2 using the magic of the GCD function. All right. So yeah, good luck, and I'll see you next time.